In this lectures, we will discuss the integration by part method. Through these lectures, we will learn step by step how to find the solution for the integral by using this type of method. Let's see how we will do that. This integration method, it is a special method and different from the other integration method. Why? Why it is that? Because the integration by part, in this method we have formula to implement the integration to get the result of the integration, and this is the formula for the integration by part method. What we have here, integral u dv equal u multiply v minus integral v du. And we have some notice for this method. The first one, notice this method of integration depends on another integral, which is this one, integral v du. We can say that we can use the method of integration by parts when the above integral is integrable. When we able to find the integral for this part, that means we can use the integral by parts method. The second note, there is no general rule of the selection process for the value u and dv, but through several tries may be necessary for the selection process before reaching the appropriate choice. And during the selection, make sure u it is possible to make the derivation for it, and dv it is possible to make the integration for it. During the practical example, when we solve the example, all this point it will be much clear. For the moment, let's see the other note. There are some important integral that we should aware of it in case if we need them. The first one, integral tan, it will be minus ln cosine. The integral for cotan, it will be ln sine. The integral for sec, it will be ln sec plus tan. The integral for cosec, it will be ln cosec minus cotan plus the constant number. Let's see some example. Let's see how we will use this type of integration by part to solve the integral. Find the integral of the following function. We have this function, how we will solve it by parts method. The first step, assumption. Assumption for the value u and dv, to substitute them in the relation of the integral by part. So this part, we will take it for u it will be equal x, and this part it will be, we will assume it dv. So dv it will be equal cosine dx. We will take the derivation for both sides. What is the derivation for u? It will be du. What is the derivation for x? It will be dx. And for dv, with integration, what is the integration for dv? It will be v. The integration for this part, cosine dx, it will be sine. And don't forget to multiply 1 divided by 5 as we learned from the previous lectures. Second step, substituting for the previous values in the integral parts formula. Integral u dv, it will be equal uv minus integral v du. U, what is u? U, it will be x. Multiply dv, what is dv? dv, it will be cosine dx. This part equal u, what is u? It will be x. V, what is v? It will be this part minus integral v, what is v? It will be this part, and du, what is du? It will be dx. We will get this result after the substituting the value in the integral by parts formula. Then after the simplification, what is the integral for sine? It will be cosine. And finally, we will get the final result of this integral. Easy and simple. We will take the assumption. The first step, we will take the assumption for u and dv and find the derivation and the integration for our assumption. The second step, we will substitute this value in the formula for the integral by parts. Let's see another example. Find the integral of the following function. We will follow the same step. The first step, assumption for the value u and dv, to substitute them in the relation of the integral by parts. What we will do? U, we will assume u, it will be x to the power 2. This one, it will be u. And this part, it will be, we will assume it for dv. So it will be dv equal e to the power x dx. Then we will make the derivation for our assumption for both sides. The derivation for u, it will be du, and the derivation for this part, it will be 2x dx. Then we will make the integration for our assumption. We will make the integration in the both sides. So what is the integration for the dv? It will be v. And what is the integration for the side? It will be e to the power x. Second step, substituting for the previous value in the integral parts formula. This is the integral parts formula, and we will substitute the value. Then it will be integral u. What is u? It will be x to the power 2. And dv, what is dv? It will be e to the power x dx equal u multiply v. It will be x to the power 2, x to the power 2 multiply v. What is v? E to the power x minus integral v du. What is v? It will be e to the power x multiply what is du? It will be 2x dx. And this is the first equation. Notice that we will use the integral by parts again to solve the remaining integrals. Here we have remaining integral. We will use the integral by parts again to solve this remaining integrals. So integral x e to the power x dx. We will use the same steps. This is the assumption. We will substitute our assumption in the integral by parts. We'll get the result of this remaining integrals. As you can see here, we put the result of this remaining integral. We will put it in the equation number 1 to get the final result of this integral. Simple. Let's see another example. Find the integral of the following function. We will follow the same step. First step, assumption for the value u and dv. U, it will be ln x all to the power 2, and dv, it will be dx. Then after we make the derivation for this assumption, it will be du equal 2 ln x multiply 1 divided x dx. And with integration for this assumption, the integration for dv it will be v, and the integration for dx it will be x. Second step, by substituting this value in the integral by parts formula, we will get this result. And we notice here we have remaining integral. How we will find this remaining integral? We will use again the integral by parts to solve this remaining integrals. Integral ln x dx. Again, we'll take the assumption for u and dv. U, it will be ln x, and dv, it will be dx. And here with derivation, we will get this result, and with integration, we will get this result. It will be v equal x. Second step, we will substitute this assumption in the integral by parts formula. This is the result of the remaining integral by parts. The last step, we will substitute this remaining integral, we will substitute it in the equation number 1 to get the final result of this integral. It is very simple. Let's see another example. Find the integral of the following function. We have this function. How we will find it? Just follow the previous step and everything will be fine. We'll take the assumption for u and dv. U, it will be equal x plus 4, and dv, it will be this part, the hyperbolic cosine for x dx. Then we will, with derivation, our assumption, it will be du equal dx, and with integration for this assumption, we will get this result. Second step, we will substitute the value, this value, in the integrals by parts formula, and we will get the final result. As you can see here, what is the integral for hyperbolic sine? It will be hyperbolic cosine. This is for today's lectures, and see you next time.